Regeneration is the process by which a water softener, any water softener, regardless of manufacturer, actually goes through. All valves, any Pentair product, the valve itself acts like a traffic cop. It directs the water where to go. In this process, what's the real driving force behind this process is chemistry, water pressure, and flow. These three things are critical to getting a good regeneration. That's what we're using these appliances and technology to do. We want a process that we can recreate and reuse for a long period of time. That's the benefit of having a water softener or a filter in the home, is that you have this regeneration process using a relatively cheap product like salt to regenerate a resin. But that's a chemical process. The valve just directs flow. So we're going to start by discussing the steps in the regeneration process. Why? Having been a technician for 25 years in the field dealing with water, if we don't understand the steps and what's supposed to happen in each step, we can get confused about what's going on in the troubleshooting process. We can misdiagnose what's going on. So we need to understand the process in order to understand how to troubleshoot that process. And this is where that informative process begins for us. So there are two methods of regeneration used in residential and commercial water softening today, practically, and they're downflow brining and upflow brining. We're going to talk about downflow brining because this is the most common regeneration process in the market. We'll get into upflow at the end, and this is not pro or con either process, as they are both valid methods to exploit the technology of cation exchange resins or anion exchange resins. Valid processes. So what is downflow regeneration? Well, downflow regeneration is also known as co-current regeneration. This means that regeneration occurs in the same flow as the ion exchange is happening inside the tank. So for our purposes, that means top of the tank down. The brine enters the top of the tank and slowly flows through the resin, causing, exchanging hardness minerals for sodium, just the reverse of what we were doing in the softening process. So the flow path determines the order of the regeneration process. So in downflow, the first step is backwashing. And to quote a resin manufacturer for one of their presentations I've attended, backwashing is critical to the life of the resin and is the most critical step in the regeneration process. And what is this step? This is where we reverse the flow going through the tank at full flow to backwash the bed, i.e. lift it up and expand it, because all media acts as a filter bed, regardless of whether you're using it for an exchange resin or activated carbon, whatever media is in that tank, it's going to act like a crude filter. So it's going to load with dirt. And in order for that resin to exchange, it can't be covered with dirt. It's just kind of fundamental stuff. If the resin bead is covered with dirt, it has no ability to contact the minerals in the water, so that dirt, oils, and greases covering it need to be removed. It's critical to the function of the product. So the water goes down the standpipe and up through the resin. This debris must be removed for ion exchange to take place properly. This causes what is known as bed expansion. It expands the bed. It fluffs it up and lifts it up, and it allows for that lighter debris to be washed off the bed. And then during the backwash, it's going to literally cause those beads to collide. Think of a bingo machine or a lotto machine with all the ping pong balls bouncing around. They're colliding off each other. Well, that action actually helps scrub the resin beads clean. And the media itself determines the rate at which we have to do that backwash. Whether if it's a resin, they all come in various weights and diameters and mesh sizes and things like that. The media itself determines the backwash flow rate. And that's something you're going to need to consult your manufacturer's spec sheet, because there are some significant differences out there in resin. Most cation resins require a 50 to 75% bed expansion to remove the debris and reclassify the bed. What does that mean? That means we have to add 50 to 75% volume to that bed to get this action to take place. That means at a cubic foot, we need a volume of 1.5 cubic feet. And that includes the space of the water in between the beads once they separate. It's not just, above the resin. It's incorporated into the volume of the resin as well. There is a minimum of 2 bed volumes of water that need to go through the tank to effectively backwash a resin bed. 3 to 4 is better. Our valves come from the factory, typically preset at 10 minutes. So depending on what your flow rate is, that'll correlate to how long your backwash needs to be. But that 2 beds of water volume is what is required for the water to go through that tank, get that media fluffed up, moved around, and scrubbed off, and that dirt out of the tank. Pressure and temperature impact the quality of a backwash. There are charts on this on every manufacturer's spec sheet. Essentially, the warmer the water, the longer the backwash is required. The dirtier the water, the longer the backwash as well, because this is all predicated upon what actual water quality you're putting it in. The dirtier the water, the longer I'm going to have to backwash to get that dirt off. It's just that fundamentally simple. You don't vacuum part of a rug and say the rest of it is clean because you spent enough time on this half of the carpet. It doesn't work that way. You've got to spend the time to get it clean. And water temperature. If we think about this one's not really intuitive, but as water gets warmer, it becomes less dense, which means it doesn't have the ability to lift that resin. It's going to slip it by it more easily. The colder the water, it's going to more easily toss that resin around in the tank. So once you get into 80-degree water temps, you're going to need to definitely look at your backwash flow rates and times to make sure you're getting that resin clean. There's a lot going on in the backwash step, and that's why it's so critical to the regeneration process. Now, the second step is brine draw and slow rinse. This is the same process. It is typically controlled, the switchover point between brine draw and slow rinse, by a float of some sort in the brine tank. Once you've drawn all the brine out of the tank, a float will shut off the valve and allow nothing but water to flow through the tank. So what's going on here? This is when the chemistry of regeneration takes place. The flow switches from reverse flow to directing flow through the brine valve and into the top of the tank. And this causes the venturi, or eductor or inductor, lots of different terms for the little venturi coming out of the system to draw brine from the brine tank. And the water runs to waste in this process, but it's going to be at a slower rate than the backwash because this is controlled by the size of the venturi. You can only pump so much water through that little guy. Now, the waste stream here will start off as tap water. This is where you're going to if you really need to, evaluate your regeneration process through a process called an elution study. The TDS, if you want to do this crudely, of a brining process will start out at tap water, and then it will spike to a peak of the highest salt concentration and should come down. That process should form a nice bell curve to determine whether or not that is actually taking place. And now, if you need to get into more functional aspects of that, you're going to need to use what's called a salometer, something that measures salt content, to track that as well. There is a crude field method of tasting the brining water during this process, and it's just with a fingertip on a tongue. We don't want to be drinking this water as it's a waste stream. But old school water treatment guys, they'll taste the water at the start. It should be tap water. It should taste like what goes to service here. And then it should go from there into a bitter taste, because you're washing off the calcium, magnesium, and iron. That water will taste bitter. And as it starts to climb that hill of that elution study, of that peak of TDS from the brine being drawn in, it should get saltier and saltier and saltier tasting as we go to where it is, intolerable. And then it should come back down into a TDS and nothing but tap water and soft water at the end of this process. So a 10% brine solution is what we are shooting for optimally to brine with. This, from chemical studies, has been determined to be the optimal brining. Our injectors are sized at specific flow rates. The average flow pressure and flow is going to be based on 60 psi. If you drop significantly below 60 psi in your brining, you may want to reevaluate your injector. A 9 to 11% brine solution is, ideal, and anything less than 8 or greater than 12 is really starting to be impactful to the regeneration process. This brining will continue, this 10% solution, which is created in the injector itself. The solution coming out of the tank is saturated. It's mixed with the injector flow to produce a 10% solution. And this will continue until you've drawn all the brine out of the tank and that air check closes. Once that check ball closes, you've now entered into slow rinse. And the valve itself has not changed any positions. Okay? The main valve on top of the tank has not changed any positions. It's still in the brine draw slow rinse phase. So once that happens, we are now dropped flow a little bit because we no longer have the flow coming in from the brine tank, and we are slowly rinsing the remaining salt and brine off the filter bed. Can you explain why 10%, beyond 10% is less effective brining? Essentially, you have the kinetics of the chemical reactions involved in cation exchange resin above 10%, specifically above 12%, especially when you hit 14%. You've got enough salt in there that the bandwidth that's going through the tank for the brining is just too concentrated. It ends up being a waste of salt when you're above a 14% brining. It's just, there's just too many cooks in the kitchen at that point in time, is really the kind of layman's explanation of it. You just got too much brine there. It's not going to really regenerate the resin in that bandwidth, because that brine is going to move through that tank based on its density in the water, okay? If you've ever seen a freshwater stream entering into an ocean, you see the brine line there where the fresh water comes in, or dirt coming in from a river into a clean lake. That line, that's what we're talking about, is that band that's going through the tank as you're brining. Above 14%, you just have too much salt there. That's really what it is. And it's not doing much. It's not being any more effective. It's just going to end up being wasted based on the kinetics of ion exchange. Now, the third step, this is rapid rinse. Now, what happens here is the valve now changes position to a full flow. Water is still flowing to waste at this point. And what this is here to do is we've now backwashed the bed, we've loosened it up, we've brined it, and now we're going to compact that bed back down for service. Why? Because if the bed is too loose, we'll get bypass and slippage and hardness leakage when this happens. So what we're doing here, once we hit rapid rinse, we actually should be getting soft water out the waistline after this runs for a few minutes. And all the excess brine should be coming off the tank. So this compacts the bed, gets it ready for service. It resettles the resin into the proper proportions for ion exchange, helps reclassify the bed, helps prevent channeling of the resin and hardness leakage, rinses out the remaining brine, and helps prevent salty water to service. So if we're getting salty water to service, we have failed to properly slow rinse the bed and failed to properly rapid rinse the bed. So we've got some issues there on why salt is still coming into the system. So this is getting ready for service. And what happens when in the backwash process and this process, what we're doing is we're creating chaos in that bed. And what's going to happen over time is the larger, heavier beads of resin sink to the bottom of the tank, and the smaller ones and bits and pieces go to the top of the tank. And we're able to backwash out broken pieces at the top. But this rapid rinse resettles all those different layers into the proper form so you get a good chemical contact of the water with the resin itself. Because this entire process of softening is based on the random chance that a hardness mineral or a cation is going to bounce off a resin bead and then react with it. That's why we have the length of the column we have, the diameter of the column we have, and the amount of media we have based on flow rates. Because this is all about the probability of calcium hitting a bead and reacting with it. We're creating the greatest opportunity for that to happen. That's why these steps are important. Now, the fourth step is brine fill. This is where the brine valve will switch from draw to fill, and this is where the brine line flow control comes into play. In the brining process, this really doesn't factor in, and this is true of all valves, not just Pentair valves. Auto control valves work similarly. The traffic cop is just a different way of directing the water. The brine line flow control controls how much water is able to go down the tube into the brine tank. The controller brine fill time controls how much water goes through that plumbing into the brine tank itself. So we have to know what that brine line flow control is, be able to know how much water we're going to get in a period of time. If I've got a 1 gallon per minute brine line flow control, I'm going to get 1 gallon for every minute of programming time. So what does that mean for us? I'm keeping the numbers simple there, obviously. 1 gallon of water dissolves approximately 3 pounds of salt. Okay? So what that means is for every cubic foot, if we're going to regenerate that bed at 6 pounds of salt, I'm going to need 2 gallons of water in the brine tank. If I'm going to regenerate a cubic foot of resin at 9 pounds, I'm going to need 3 gallons of water. 3 times 3 is 9. 3 gallons of water, 3 pounds of salt per gallon, 9 pounds. 15 pounds of salt, 5 gallons of water. You're going to program this step based on the brine line flow control's gallon per minute rating and program the appropriate amount of time into the valve. to fill the tank. This is where you get the control over the brining process. Now, the fifth step here is to return the valve to service. And the system is already producing soft water because the bed has been regenerated in the regeneration process and rinsed clean. And now you're back to softening water. So all the valve has done is direct water through different places inside its head to cause water and brine to be drawn into the tank. All the chemistry is going on is because of the tank, of the water chemistry itself. Yes, we'll get into talking about brine tanks specifically in the future. I'm just separating that out. Someone had made the comment, note there is a 40% void between salt in the brine tank. So it may not actually have the 2 gallons of water due to displacement, hence brine grids are important. Yes, brine grids are actually important, but you know what? I'm going to quibble a little bit on this one. You put 2 gallons of water into a brine tank, there is 2 gallons of water in there, regardless of the amount of salt that's in the tank. Yes, it will fill the volume between the grains of salt and create a higher level of water in the tank, but there is still only 2 gallons of water in that tank because the space is taken up by the salt. And then when you dissolve that salt, yes, you are changing the volume of that solution a little bit to actually increase in size just a touch. That's why we don't meter the brine draw cycle explicitly based on time or volume. Why? Because we know the process of adding unsaturated water to a brine tank to saturate it with salt will cause that volume to change. But that's really inconsequential to most brining situations because we are drawing that brine out until a physical float comes down and seals off that tank. We are never removing all the water out of the brine tank. There's always a little bit left at the bottom. So it's really one of those technical discussions that really will play a part if you're dealing with a brining system or a brine tower. And that's a different animal than a traditional brine tank scenario. So the discussion of brine tanks, that's even in that situation, most of the time the brine's delivered in a different process, typically with a pump, and you're going to factor that in with a pump rather than the traditional Venturi draw. So yes, that is a valid statement, but it's applicable to certain circumstances. Now, upflow brining, this is one of those topics that if you walk into a room of water treatment professionals and go, let's talk about upflow brining, you may have a bit of conflict on your hands. And you know what? From an outside standpoint looking in, as a chemist, I see the value of this. But like any process, you have to do it the right way to see the effectiveness. Just switching a valve over from downflow to upflow is not necessarily going to see or provide much benefit. Okay. Now, upflow regeneration. What does this mean? Upflow is also known as countercurrent regeneration, which means we're going to regenerate the bed in the opposite direction than we do in downflow. We're going to put the brine in at the bottom of the tank and push it up through. This process, because we're changing that flow, we're going to change the process and the order of events that valve has to go through to do this properly. Now, there is a whole lot of technical details in doing upflow brining properly. I would suggest if you are going to do upflow brining that you either use a valve that uses soft water refill for your brine tank, or you have a separate source regeneration of soft water. Why? Because it really doesn't pay in this circumstance to use hard water to brine with. You're going to impact the process in a way that you don't wish to from a strict technical standpoint. So the brine draw is the first step typically in upflow regeneration. Why? Because we don't want to fluidize the bed with a backwash. We want that bed nice and compact. And really, to be honest, we want upflow brining to happen really, really slowly, or have some sort of physical device in the tank to keep that resin bed compacted so it's not lifting up. There are devices out there you can put on top of a tank that will only rise up when you go into a faster flow scenario in upflow brining. So there are ways to manage that if you can't directly manage that with flow on site. Some technicalities here. So what we're going to do is we're going to have the brine draw be the first step. It's upflow. That means the brine is being pulled out of the brine tank and down the center standpipe and then up from the bottom. Why? Because most softeners have a 10 to 20% reserve capacity built into it. So that bottom 10 to 20% of resin never sees any hardness and is never really has the need to be regenerated. So all your brine hits resin that only needs to be regenerated, and the mineral content leaving the bead is going past resin that's already exchanged for hardness. So what you get here is an ability to save on salt and water and get more capacity out of your bed, but it has to be done well. The next step, brine refills the brine tank for the next regeneration, getting it set there. Some units will put the brine refill in front and then pause for 2 hours and then do the brine draw. Semantics at this point in time. And then after that brine draw, we've regenerated the bed, we've refilled the tank, backwash. Now we're going to backwash the unit, reclassify the bed after it's regenerated, and backwash all the dirt and debris off. Now, it's also important to understand that, if that's not soft water, you may have an issue there as well. So upflow brining is really about the details. Got to get the details right to nail this. And then rapid rinse reverses flow and packs the bed for service, and then service. So if you understand the order of the steps, you understand what should be happening during that step and what you should be getting out the waistline. Because in all actuality, when we're out troubleshooting softeners, what do we really have access to get data from? It's the waste stream. We know what should be coming out of that pipe at what given point in the process. So backwash, we should see the water go from clean to dirty and then back to clean again in a nice bell curve over time. And the same thing happens with brining. We should see TDS follow a nice bell curve from tap water back to tap water. If you want to use a salometer to know where your salts are coming off of, same thing to evaluate that process. We should know that in rapid rinse, when we're done rapid rinsing a softener, no matter which one it is, that water should be soft. Do you lose some capacity after you backwash and rinse after you've brined? Yeah, you're going to lose a little bit. Hopefully, because here's the game we're playing, is if we're backwashing or we're pushing flow fast enough up through it backwards, how much time do we have for the exchange kinetics to happen? So there's a lot of technical details with upflow brining that if you're dealing with high purity water applications, you need to nail this, right? But in a residential situation, if I'm using an Upflow softener, I'm not as concerned about that issue as I would be in process plant water or high volume treatment water in a commercial space, or high purity water, like for semiconductor manufacturers and things like that. If I need to make sure I need to maintain specific chemistry for a specific process, yes, I am going to want to make sure I nail these details for those outcomes, because those are greatly impactful to those establishments. So yes, you might lose a little capacity if you are not regenerating with soft water. That's why upflow brining, you'll see that used a lot in twin alternating tank systems that where they're connected, where the second tank is really now online, and it's nothing but it's a water softener feeding the softening process for the other tank. That's where upflow brining really, really pays off, is when you have that separate source that's providing soft water for all these processes. And even in large scale operations, they may even have a separate softener just to provide water for the regeneration process. It really depends upon the water chemistry involved and the application that water is going to, if you're going to consider upflow brining. I mean, residentially, we have products that do that. You will see a savings there, but that the little technical details aren't as critical in a residential application as in commercial. And when you start doing commercial upflow brining, dot your I's, cross your T's. In those circumstances, reach out. All these resin manufacturers and valve manufacturers all have great technical staffs that will help you nail these details. And they have programs and systems that will dial in what you need to do. Now, they're going to take the real world factors and help you do that. At Pentair, we make valves and tanks. We don't make resins. Okay? We make the components that allow you to execute this chemistry in the field. We make versatile and functional tools to do that. But you need to take our products and our tools and work with the people that create the chemistry behind what our tools do well. And what you put in the tank, work with those people to really understand the kinetics of it, especially if you're considering upflow brining for commercial applications. Spend the time to get it right. That's what I can urge you, being a former service guy and technician. If you get the details right from the start, you tend to have less issues. But the reality of water is water treatment, and it changes and it's variable. It is an active endeavor. It is an engaged process. There's no set it and forget it, because you're dealing with a product that's always changing. So feel free to go ahead and ask a question at this point in time. Let me go back to the, wonder how I skipped. Feel free to unmute yourself if you have any questions you want to ask. Yeah, we will be doing later on in the series a presentation just on brine tanks. We'll be doing just on injectors. We'll be doing just on backwashing the media itself. So today's discussion was just a discussion of the steps. Lots of great questions being asked via chat. Love that interaction. Please keep it coming. And by the way, if Mark, you got a question? If not, feel free to enjoy the rest of your day. But we just wanted to make you aware of a new initiative by our training team. And that is I forgot a G. It's training. I can't type this morning. And I can't talk and type at the same time either.
David, do you have time for a question?
Absolutely.
Okay. Just real quick, and I know this is kind of a gray area or a touchy area for a lot of OEMs and manufacturers of equipment. I'm seeing that you make your valves and somebody else makes the resin. You make your valves. You put a flow parameters around and specifications around your valves to be X. And then the resin manufacturers use theirs as a certain, so let's say half a gallon a minute to 10 gallons per cubic foot of resin. You see out there numerous companies providing equipment that far exceed those parameters, especially on commercial and industrial applications. Your recommendation for flow rates for resin, what are those and how they compare to what your valves are actually doing?
Well, you know what? There's a difference between the flow rate of a valve and the flow rate of the media, right?
Sure, definitely.
Because our valves you can put any media you want in there, right? You can put, correct. There's Catalogs, there's cation exchange resins, or anion exchange resins, filters, saying if you want to go simple. All that stuff operates within its own context. And that's the reason why we specify our products by their flow characteristics. Why? Because we can't comment on what you're going to put in that tank. We're making a versatile tool. Okay. Who hasn't taken a flathead screwdriver and used it as a chisel? Right. That's the sort of, we're making a tool for you to use. So it's incumbent upon anyone putting something in that tank to understand what they're putting in the tank. And will it match up to what the valve can do, right? I can say honestly right now, every one of our valves is over-designed for water softening resin because the media is so light. We can backwash it very, very easily. It's when you start putting heavier medias in that becomes critical, and you may have to adjust your flow controls and your other processes as well. AIO, air-induced oxidation. It's still a water softening valve. It's just using air instead of brine. You can use lots of different medias in that tank and still affect the same process. So the way we're doing things, it's kind of like the only analogy I can really think of is going out and buying an engine for your hot rod, right? You put a stock engine in your car and then you soup it up. That's what you're doing. And we are not trying to take away any creativity from the marketplace using our products to treat water. And that's where we've always kind of tap danced around applications because we don't speak to resins, right? And that's one of the reasons why, we're spending time building presentations to start talking about resins and how they work with our products. Because you're hitting on the exact point. Well, your valve says it can do 100 gallons per minute. Why am I getting, hardness bleed through? Well, the amount of resin you have really only needs 60 to 70 gallons per minute. Right. Pushing too much water through. And I find that to be indicative of not understanding the process.
Correct.
Okay? Understanding the materials. And really it's kind of an interesting place being in the service world. Because guess what? In the swimming pool world, same thing with medias. What do you put in that tank? What are the flow requirements I need? How do I adjust that to be optimal? That's where professionalism comes in. That's where treatment and, that's why you hire treatment professionals, is for that knowledge. That's where your value is as a dealer and an OEM comes into play. Because let's face it, if Pentair started packaging tanks and filling them with resins, we would be selling a system. We want to sell components. We want to give you the ability to be flexible enough to address water conditions wherever they exist. And that's something we don't want to hamper. We want your creativity. We want you guys. Yeah, there's so many different ways to tweak this process into something proprietary, as long as it meets the requirements of what's in the tank. We do have one of the gentlemen from our Pentair friends in India have asked about the commercial ordering guide. I would suggest questions about that we possibly schedule some time to go over the commercial ordering guide explicitly. Okay, that is probably too much to go into in this conversation. We should probably dedicate some time to that. And if you have any training requests for the future, there's a new email box this year. It's training.requests@pentair.com. And that's directly to Mark and myself. And we can arrange training for you, whether it's in person, hopefully after we get past this COVID thing, troubleshooting, anything, just to sit around and talk shop and discuss an application. We can do that. If you just want to let us know problems you're having with a product, let us know. We don't, because, I'm literally an hour and a half from the plant. I can go up and talk to an engineer. We report out after our trainings what we learned from you guys. We want to speed up process improvement, and we need that from the street level. So let us know. We'll be a shoulder to cry on or an ear to chew about whatever issues you got, and we will try to put those in the right ears to affect change quickly. I know I've been a service guy. I know what it feels like to go, is anybody listening to us? We're telling you you've got a problem here. Well, I can go find the engineer and the product manager and talk to them directly about what I'm hearing from you guys. So we're a channel for that. And the new ordering guide, if you've seen it out there, we'll be doing talk to your salesperson about that. And if you are an internal person and need help with that, schedule some time with Mark and myself to go over that with you. Have a wonderful rest of your day. Hopefully it will be profitable and uneventful. And this has benefited you somewhat. Thank you very much. Have a wonderful day.